password-based safety locker. Oftentimes, we need to secure our valuables at our home or office so that no one can access them without our permission, and ensure protection against theft or loss of our important accessories and assets. There are so many types of safety lockers present today, but behind the scene, for authentication, they all rely on fingerprint, retina scanner, iris scanner, face ID, or password-based PIN. Of all the solutions, the low-cost one is to use a password-based system. So, in this project, we will see how to build an Arduino-based password safety locker. Here is the connection diagram of this project. 16x2 LCD display has 2 lines. Each line can display 16 characters. This display has 16 pins. First pin is ground, second is VCC, then contrast, RS, RW, enable, D0, D1, D2, D3, D4, D5, D6, D7, VCC, and ground. Pin 1 and 2 provide the supply for its internal circuitry, and pin 15 and 16 provides the supply for its backlight. We have connected pin number 1, 5, and 16 with the ground pin of Arduino, and pin number 2 and 15 with the 5V. Pin number 4 of LCD is connected to the pin number 12, and pin number 6 of LCD is connected to the pin number 11 of Arduino. Pin 7, 8, 9, and 10 are not used. Pin 11, 12, 13, and 14 of LCD display are connected to the pin 5, 4, 3 and 2 of Arduino respectively. A 16-button keypad has 4 rows and 4 columns. It has 8 output pins. 4 pins are connected with the rows, and 4 pins are connected with the columns. Pressing a button will short one of the row output to one of the column output. From this information, the Arduino can determine which button was pressed. For example, when key 3 is pressed, column 3 and row 1 are shorted. Arduino detects it and inputs 3 to the program. We have connected row 1 of keypad with a 0 pin of Arduino, row 2 of keypad with a 1 pin of Arduino, row 3 of keypad with a 2 pin of Arduino, row 4 of keypad with a 3 pin of Arduino. We have connected column 1 of keypad with a 4 pin of Arduino, column 2 of keypad with a 5 pin of Arduino, column 3 of keypad with pin 0 of Arduino, column 4 of keypad with pin number 1 of Arduino. We have connected the positive terminal of buzzer with Arduino's pin number 8. Negative terminal of the buzzer is connected to the ground pin of Arduino. Servo motor has 3 wires, red, orange, and brown. Connect the red wire with the 5V pin of Arduino. Connect the brown wire with the ground pin, and orange wire with pin number 9 of Arduino. Orange wire is used to give control signals to the servo motor. HX711 weighing scale sensor has 4 pins on one side and 6 pins on another side. 4 pins are VCC, ground, SCK, and data. 6 pins are A+, A-, E+, E-, B+, and B-. VCC pin is connected with the 5V pin. Ground pin is connected with the ground pin of Arduino. Data pin is connected with pin number 6 of Arduino, and SCK pin is connected with pin number 7 of Arduino. This is the code of our project. To control the LCD display, we will first include its library in the program. To include the library, we will write in the first line, #include liquid crystal.h. Now we will declare the name of the used pins in the sequence of RS, enable, D4, D5, D6, and D7. We have connected RS pin of LCD with pin number 12 of Arduino, D7 of LCD with pin number 2 of Arduino. Now we will include the library of the keypad. To include the library, we will write #include keypad.h. Now we have declared 2 variables. One is rows, and second one is columns. We have given value 4 to both the variables, because we are using 4x4 keypad. Now we have declared a 4x4 2D array, hexa keys, and give the name to each array location. Now we have declared two arrays, row pins and call pins. Each array has 4 locations. In this array, we have declared that which pin of Arduino is connected with the row pin of keypad, and which pin of Arduino is connected with the column pin of keypad. This line will take the values of variables from the previously defined values. Key, num1, num2, num3, and num4 are character type variables. To control the servo motor, we will include the servo library in the program. To include the library, we will write #include servo.h, servo space myservo. Myservo is a variable which will store the value of the angle at which user wants to rotate the servo. We have connected a buzzer at pin number 8 of Arduino. To control the weighing scale, we will include its library in the program. To include the library, we will write #include hx711.h. Data pin is connected with pin number 6 of Arduino, and SCK pin is connected with pin number 7 of Arduino. Void setup is a function in which we will declare the input and output pins. We have declared pin number 8 of Arduino as output pin. Signal pin of servo motor is connected at pin number 9 of Arduino. LCD.begin 16,2. It means we are using 16 columns and 2 rows of the LCD display. Scale.set scale. This function is used to calibrate the scale with known weights. Scale.tr. This function is used to reset the scale. Void loop. This function will run over and over again, so whatever we write inside, it will repeat forever. LCD.clear is used to clear the LCD display. myservo.write 0. This function will set the servo position to angle 0. LCD.print. Enter password. This function will print the message, enter password, on the LCD screen. LCD.set cursor 0,1. It will change the line, while key equal no key. This function will wait for any key to be pressed. Key equal kpd.get key. This function will scan the keypad. If any key is pressed, then variable key will store the name of that key. LCD.print will display the name of that key on the LCD screen. Now we will save the key name in the variable num1. It will be the first digit of our password. Similarly, we will save the rest 3 digits of the password in the variables num2, num3, and num4. Our default password is 1, 2, 3, 4. If entered password will match with the saved password, then Arduino will print the message on the LCD screen that password is correct. Then it will rotate the servo motor 90 degree. LCD.print scale.get units. This function will print the raw output value of weighing scale on the LCD screen. If output value is greater than 10, then Arduino will turn on the buzzer. If entered password do not match with the saved password, then Arduino will print the message on the LCD screen, wrong password. If password is incorrect, then Arduino will turn on the buzzer. Now, we will write a code on this software. After writing the code, we will save our project. Now we will compile our code. For doing this, press this check button. If there is any error in the code, or the code is incorrect, it can be seen on the message screen below. If the code is correct, we can upload it to our Arduino hardware board. For this, we will first connect the Arduino board to the USB port of our computer. Now we will go to the Tools menu and select Arduino Uno. Then, we will go to the port option and select the port at which Arduino is connected. Now, to transfer this code to our hardware, we will press this arrow button. Now we will assemble our hardware. We will take 3 wires, 1 red, and 2 black. We will use these wires later. Now we will solder a black wire at hole number 1, and red wire at hole number 2 of LCD display. Now we will solder a white wire at hole number 4, and brown wire at hole number 6 of LCD display. Now we will solder orange, yellow, green, and blue wires at pin number 11, 12, 13, and 14 of LCD display. Now connect hole number 16 with hole number 1 using a black wire, and hole number 15 with hole number 2 of LCD display using a red wire. Now connect hole number 5 with hole number 1 of LCD display using a black wire. Now connect hole number 3 with hole number 1 of LCD display through a 1 kilo ohm resistor. Now we will connect the LCD display with our Arduino hardware board. Connect the red wire with 5-volt pin and black wire with the ground pin. Now connect white, brown, orange, yellow, green, and blue wires with pin number 12, 11, 5, 4, 3, and 2 of Arduino respectively. Connect the gray wire of keypad with pin A0 of Arduino, purple wire with pin A1, blue wire with pin A2, green wire with pin A3, yellow wire with pin A4, orange wire with pin A5, red wire with pin 0, and brown wire of keypad with pin number 1 of Arduino. Connect the red wire of servo motor with VCC pin, brown wire with the ground pin, and orange wire with pin number 9 of Arduino. Connect the red wire of buzzer with pin number 8 of Arduino, and black wire with the ground pin. Connect a red, black, yellow and green wire at VCC, ground, data and SCK pin of HX711 sensor. Connect the red wire of HX711 sensor with the 5-volt pin, black wire with ground pin, yellow wire with pin 6 of Arduino, and green wire with pin 7 of Arduino. Now we will power up our circuit and test its functionality. We will first enter the password. Stored password is 1234. If password is correct, then Arduino will rotate the servo motor and open the door of locker. Now when we put the object, then Arduino will turn on the buzzer. Now if we enter the wrong password, then Arduino will turn on the buzzer to alert the authority. I hope you enjoyed the video and learned something from it. For any help in your project or to clear your doubts, you can contact us on our student care number 7007957715. To purchase the items used in the video, you can visit our website www.erolltech.com. You can order us on our WhatsApp number also. Thank you so much.